Hey guys, Mr. Reddy here. Like what we've done in the last couple weeks, we're going to go ahead and do some quiz corrections today. So like last time, you're going to watch the question the first time. All you're doing is looking for your mistake. So there's no writing really the first time. You're just examining what's on your quiz versus what you should have had if the answer was correct. So you're going to go through and watch. After that, you'll redo it and correct it. And in the right box, please make sure you're writing down where your mistake was. Now, we had some people last time that just put, my mistake was I got it wrong. Or my mistake was I missed a question. Well, we know you got it wrong. We know you missed the question. You need to be specific on your mistake. So specifically, your mistake was you didn't add -2 instead of subtract it, or whatever the case is. Specifically put that. Really, other than that, we did a good job with our corrections. We just need to make sure we are specific with what we are doing. I'm going to go ahead and show you. If you need to fast forward to other questions, you can go ahead and do that. Question 1 will start obviously right after I'm done talking, and then you can fast forward if you need question 2 or question 3 only. Okay? Again, the goal for today is to check our mistakes and to learn from them and correct them before we move on into some more practice. Okay? All right, here we go, guys. So this was question 1. So if you missed question 1, we're going to go through it. Now, one thing we look for, remember, with elimination is we're trying to decide if there's any coefficients that are the same. Now, we see our x coefficient is 6 and 6. So that helps us. They're already the same. So if they're already the same, there's no need to multiply. We go straight into either adding or subtracting. Now, we talked about in our foldable, same signs mean we subtract. So since it's +6 and +6, we're going to be subtracting these two equations. So what you should have done is you should have turned this problem into one giant subtraction problem. So I'm going to draw my line, subtraction, and I'm going to split my equation. So here's my equation split. And then from here, we're just subtracting. So I start from the left, and I know that 6x minus 6x cancels out. So the 6's are gone, or the x's, excuse me, are gone. Let's move over to the y's. +5 minus -7. Now, if I'm subtracting with a negative, remember, a minus and negative actually switches to positive or addition. So really what we had was we were adding 5 and 7. And I know that 5 plus 7 gives me 12y. So we should have had 12y here. So you're going to check and see if that's what you had. So here's 12y. Okay. Let's go down to the next part. So I have +4 minus -20. +4 minus -20. Now remember again, same thing. If I'm subtracting and there's a negative, that flips that to addition. So it's really 4 plus 20. And I know that 4 plus 20 gives me 24. Okay, so then from here, I'm just ready to go ahead and solve this. I know that to move my 12 to the other side, I have to do the inverse of multiplication, which is division. So I should have divided both sides by 12, which cancels out my 12s with the y. And I'm left with y equals 24 divided by 12, which we know 24 divided by 12 is 2. So our y value was 2. Remember, from here, we want to put this back into one of our other equations. Remember, we have some options here. We've got the top option, which is 6x plus 5y equals 4. The second option is 6x minus 7y equals 4. Well, we want, if this was me, to use positive numbers instead of negative. So I'm going to take this 2, and I'm going to put it back in for y in our first equation. So I'm going to draw my arrow up here, draw it up, and it's going back into our top equation. So I'm going to have my other arrow going out where I'm going to show you my work. So I ended up with 6x plus 5. Then instead of y, remember, since y equals 2, we're going to put a 2 in our parentheses. And that's supposed to equal +4 in the end. Okay, so now we're here. We start with our parentheses. 5 times 2 gives me 10. So I have 6x plus 10 equals 4. So now I'm here. So we want x by itself, which tells me I need to move the +10 to be with my other constant. So since 10 is a constant and 4 is a constant, I want to combine those like terms. So the inverse of +10 was -10. So my 10's cancel each other out, and I know if I'm at +4 and I subtract 10, that's going to cross the equal sign and get me into the negatives. So I should have had -6 on the right side, and I'm going to bring down my positive 6x. So I have 6x equals negative 6. From there, I just divide because I have a coefficient of 6 with the x, so I want to divide by that coefficient. And I know a negative 6 divided by a positive 6 gives me an answer of negative 1. So what that tells me in the end is that x is negative 1 and y is positive 2. And as we know, that's like if we graph these and they intersect or they cross at negative 1, 2, that's a one solution answer. Okay, and there would be our answer for question 1. So corrections that need to be done, go back, rewatch this video, do your corrections, and figure out where your mistake was and write that to the right. Remember, be specific. So let's look at question 2. So if you missed question 2, we're going to go through that question now. So again, remember what we talked about? We said we want to look first for any coefficients that are the same. So we see x's have 5 and 3, so we know those aren't the same. And we know that our y's have just y and 2y, and we know those aren't the same. So to help us, we kind of need to know that there should be a 1 in front of this y. So we've talked about this before. If you have a variable by itself, there should be a 1 in front of that variable. So I'm going to go ahead and I'm going to put a 1 in front of mine. So that's going to help us a little bit. So if we have no coefficients that are the same, which we don't, then we know we need to multiply. So let's think about this. Can I multiply 5 by a whole number to give me 3? We know we can't do that because 5 times 1 is 5 and we already skipped 3. Let's flip it. Can I multiply 3 by something to get 5? Well, we know that's not going to work either because 3 times 1 is 3 and 3 times 2 is 6, so we missed the 5. So let's come over here. Can I multiply 1 by something to make it a 2? Well, we know that we can multiply 1 times 2, and 1 times 2 would give me 2, which would be the same. So that tells me I want to multiply this entire top problem by 2. So I'm going to take my top problem down here and I'm going to multiply everything in it times 2. So every single thing in this problem is getting multiplied by 2. Now remember, when we do this, since there's not ever really a lot of room to work on these, we're going to write our answers down below. So we know 2 times 5x is 10x. So I'm going to write that down below, 10x. Then I do 2 times positive 1, which gives me positive 2y, and then 2 times 15 equals 30. So all I've done is basically distribute and multiply everything times 2. So my next thing I need to do is bring my other equation down to where it should go. So it says 3x plus 2y, and that's going to equal 9. And now we're ready to work this out because we have our two problems. So let's look at what we have now. We know that by multiplying, we got our 2y to be equivalent or the same as 2y. So our next step is to look at the signs. Remember, same sign, you subtract them. Different signs, you add. Well, we see they're both the same sign, so we should subtract in this case. So like our other problem, we're going to turn this into one big subtraction problem. So I'm just splitting my problem up. And it's going to be subtraction. So I'm subtracting this. Okay, so let's go through our steps. So I'm starting with the 10x. So 10x minus 3x is just like 10 minus 3. So 10 minus 3 should have given me 7x. So I'm going to write that down below. So I have 7x. Okay, let's look at our y's. I have 2y minus 2y. And 2 minus 2 is 0. So that's what eliminates our y's. So I don't have any more y's left. Let's look at our last column. 30 minus 9. Okay, 30 minus 9, I know they're both positive. So 30 minus 9 gives me 21. So I end up with 7x equals 21. So my last step here is just to figure out what x is by dividing our coefficient, which is 7. So I'm going to divide both sides by 7, and x equals 21 divided by 7 equals 3. So my x value should have been 3. Now again, remember, we want to sub this back into a different equation. So we really have a lot of options here. We have the top equation, 5x plus y equals 15. We have 3x plus 2y equals 9. We have 10x plus 2y equals 30, and then a repeat of that second equation. So I don't know about you, but the second equation is by far going to be the easiest of these three. So I'm going to draw my arrow up, and it's going to be pointing to that second equation. Okay, and from there I'm going to rewrite my second equation over to the side. So I have 3, but instead of x, I know that x's value we already found was also 3. So I have 3 times 3 plus 2y, and we know that's going to equal 9. So the next job you had was just to solve this. So 3 times 3 gives me 9. So 9 plus 2y equals 9. So now I'm here. I know that I need to get my constants together. So I have a constant of 9 on the left side that I need to move over to be with the other constant. If our 9 is positive, I need to subtract 9 from both sides. So my 9's cancel out on the left side. And on my right side, 9 minus 9 leaves me with 0. So now I need to look on the right side. I still have some 2y right here to bring down. So positive 2y gets brought down. So hopefully we're starting to see now that 0 is on the right side what our y value is going to end up equaling. So when we divide everything by 2, well, we've talked about this before, I can't split 0 into 2 parts because it's just 0. So that tells me my y value equals 0. So then again, I want to write it as an ordered pair. X is 3, y is 0. And we know that that means they cross each other or intersect at that point, so it is a one solution answer. Okay, all right, so let's go on to number 3 if you need that one corrected. Okay, so let's look at question 3 if this was the one that you missed. So on question 3, again, we start by looking. We have a 4x as a coefficient, a negative 4x as a coefficient, and positive 3, so those are not the same. Positive 9 and negative 4, those aren't the same. So that's the first step that we look for. The next step we look at is whether or not we can multiply one equation to get the second equation. So let's look. Can I multiply negative 4 by something to make it a 3? Well, no, we can't do that. Let's flip it. Can I multiply 3 by something to make it a 4? Can't do that either. Let's go to the y's. Can I multiply 9 by something to make it a 4? That doesn't work for me. And can I multiply 4 by something to make it a 9? And we still can't do that. So what that tells us is if there's nothing we can multiply one equation by, we're going to have to multiply both equations. So again, we talked about this. Think of it as like with fractions, you have to find a common denominator. So we're going to use whatever would be smallest as a common denominator, think of it like that, to work this problem out. So I know that if I wanted to get my x's the same, I would multiply 4 times 3. 4 times 3 is 12. So 12, remember that number, 12. Okay. If I wanted to get my y's the same, it'd be 9 times 4. 9 times 4 is 36. So let's think, which number would be smaller, 36 or 12? Well, I know 12 is smaller, so that's going to kind of tell me which one I want to multiply because I want to use smaller numbers. So remember when we do this, we multiply by the other coefficient. So we're going to take negative 4 and we're going to multiply this whole second equation by negative 4, and then we're going to switch and take positive 3 and multiply the whole top equation by positive 3. So let's look and walk through that. So again, we're taking negative 4 here, and we're going to times the entire second equation by negative 4. So let's do that. So I know negative 4 times 3x is negative 12x, so I'm just writing this down below. And I know negative 4 times negative 4 is positive 16y. And then finally, I know negative 4 times positive 10 is going to equal negative 40. Now, we've talked about this before, but the order of our equations matter. So when we are going to redo our first equation, it still needs to be first when we rewrite it. So now let's take our top equation, and we're going to multiply this whole thing by 3. And again, we're getting that from our two coefficients. So there was the 4, and there was the 3. So let's try that now. So 3 times negative 4 gives me negative 12. Now remember, it's got to go first because it was first originally. 3 times 9y, well, that tells me I have 9, 18, 27y. And then finally, I have 3 times negative 17, which gives me negative 51. So now I have my two equations, and I can examine them to see if I'm going to add or subtract. So again, we're looking, our x's now have the same exact value. They even have the same sign, and we know from previous problems that if they're the same sign, this becomes one giant subtraction problem. So we're going to take our pencil, and we're going to make this into a big subtraction problem. So I'm doing that on mine, you're doing it on yours, and now it's time to solve this. So I start from the left. Negative 12 minus negative 12. So that's kind of weird. Again, we have a negative 12 and a minus sign. So this flips to really adding, remember. So negative 12 plus 12, and those cancel out or zero out. So they are eliminated now. Let's move over here to our y's. So 27y minus 16. Okay, I know 27 minus 16 is going to leave me with 11. So I have 11y. Okay, let's look at our last part. A little tricky here because we have a lot of negatives again. Okay, then on the right side, I have negative 51 minus negative 40. Again, similar situation. I have subtraction and a negative, which flips it to addition or positive. So it's really negative 51 plus 40. And if I'm at negative 51 and I add 40, so I'm going back towards 0, that's going to end up at negative 11. So I have 11y equals negative 11. So I know my last step again on this side is just to get that variable by itself by dividing by our coefficient. So our 11s on the left side cancel each other out. And I end up with y equals negative 1, because negative 11 divided by positive 11 is negative 1. Okay? So from there, we just sub it back in. We have a lot of options, but we've talked about this on our foldable. Don't use the ones that are multiplied, because these numbers are all way larger. Okay? So then we should examine these top two. In my first equation, I have a couple negatives, while in my second equation, there's only one, negative 4. So that tells me, just based on the fact that I'd rather use positives, that I'm going to take my negative 1y and I'm going to use it in the second equation. So I'm going to take my arrow and I'm going to draw it up to the second equation. And when I slide it over and rewrite it, I have 3x minus 4. But again, instead of y, I know that y is equal to negative 1. So I have negative 1 equals 10, and then from here I'm just solving this out. So I have negative 4 times negative 1. A negative times a negative gives me a positive 4. So I'm going to bring down my 3x. So 3x plus 4, because that was positive 4, equals 10. Again, I want to get my constant of positive 4 over to the other side to get our variable by itself. So I'm going to do the inverse of addition, which is subtraction. And I subtract 4 to eliminate my 4's from the left and to combine my constants or my like terms on the right. So I know that 10 minus 4 gives me 6. Over on the left, I'm going to just move my 3x down, and I'm left with 3x equals 6, which leaves me with dividing by our coefficient. And finally, I know that 6 divided by 3 is 2. So I have an answer of x equals 2, y equals negative 1, and as we've talked about, that means they're intersecting on a graph at positive 2, negative 1, which is an example of one solution. So I have one solution for question 3. All right, so hopefully this helped you guys with your corrections. Remember, I am looking for specific reasons of why you missed the question. So please be specific in your explanation, okay? Great job, guys.